Okay, hello and welcome to lesson 8 of Inequalities. And so we've been building up to this one, solving quadratic inequalities in one variable by factorising and sketching the graph to find critical values. So if you haven't done already, please make sure you've done lesson 6 and lesson 7 because they involve factorising and solving and sketching quadratics. And it's important that you practice those skills before you do today's lesson. So, your title will be Solving a Quadratic Inequality. And as I said in a previous video, this topic is generally around kind of grade 8, grade 9, that sort of area. But as long as you are comfortable with factorising and solving and sketching, then there's not too much more to understand to be able to answer one of these questions. So what we're looking at is this. So you've got to solve this quadratic inequality. Now, it starts off very, very similar to what you would do normally with just a solving question where it was equal to 0. Now, I understand this is less than 0, but we assume at the beginning that it's just equal to 0. So what you would do normally is you would look to factorise that quadratic, which means two numbers that multiply to make negative 20 and add together to make negative 1. So what we're looking at there, once you go through your list of factors of 20, is you're looking at x minus 5 and x plus 4. And you can leave it like that. You could write equals 0 at this stage if you wanted to, because we're just going to identify the values of x that are important. So we've got those brackets there. We then do the solving part. So we say here, x equals 5 and x equals negative 4. Now, rather than solutions to this equation, these are what we refer to in that first point here as our critical values. Okay, so they are the critical values. Now, they're not technically solutions to this problem. If this was equal to 0, yes, you would say those are the answers. But because it's an inequality, these are not the solutions, but they are critical values to our sketch and therefore our answer. So we can write that, but we need to understand that they are the critical values rather than the solutions. So in terms of how our sketch looks, we're looking at x is negative 4, so somewhere around here, x is 5, so over here somewhere, and we've got a quadratic like that. And now there's nothing new so far, so that's just what we did last week. Now, this is the new bit. This is the bit that people sometimes get confused with as well. So what we're looking to do is we're looking for when this equation is less than 0, okay? And so we're looking on our graph, and we're looking for where our graph, our y values on our graph, are less than 0, okay? So if you think about any coordinate on this curve, you might look at a coordinate, say, around here, and think, well, the y-coordinate there is probably, I don't know, 4, 5, 6. It's going to be positive. The y-coordinate here would be positive. But the y-coordinate here would be negative, and here, and here, and here. All these y-coordinates here are negative. And so if we're looking for when this is less than 0, we're looking for this bit here. Okay, that's what we're looking for. We're looking for that part of our graph there. That's when it's less than 0. And now in terms of writing an answer for that, if you look at my x values here, my x values are in between negative 4 and 5. So I write that as x needs to be greater than negative 4 and less than 5. Okay, that's how I'm describing these x values in between here. So all these x values are in between negative 4 and 5. They are greater than negative 4 and less than 5. So that is my answer to this question. Okay, that's my answer to that inequality, solving that quadratic inequality. Now, I would like you to copy that down. I'm going to do a couple more examples. It's going to be 4 examples today. I would like you to copy all of them down because they're all slightly different. And so this is an example where you've got less than. Now, if we look at this example, it's very similar. We're still looking at less than, but it's less than or equal to. It doesn't change our method at all until right at the end when we write the answer, okay? So we're still looking to factorise initially, looking for numbers that times to make 12, add to make negative 7. So because they need to add to make negative 7, they're both going to be negative. So negative 4 and negative 3. So something like this. Now, critical values here. Quick sketch. I'll do it over there. And we've got a quadratic that looks like that. Now, again, because we're looking for when this is less than 0, we're looking for when it's below the line, okay, below the x-axis. So all these points here would be less than 0. In terms of our y-coordinates, they would all be less than 0. So when I write the answer there, I'm looking for x to be greater than 3 or less than 4. But the last thing you've got to do is just refer back to your question. And if you see in the question you've got equal to, you need to make sure you have equal to in your answer as well. So it's just about mirroring that final inequality in terms of if that's equal to, that should be equal to as well for our answer. So again, I'd like you to copy that one down. Now, the big change really comes when we go to greater than, okay? And this takes a bit more explaining. But initially, we're doing exactly the same thing. We're looking to factorise that initially. So, relatively simple, this factorising, times to make 3, add to make 4, so 3 and 1. Critical values here, x equals negative 3 and x equals negative 1. So, sketch, we're looking at something like this. Now, this is where it changes slightly. We're looking for when this graph is greater than 1. So if we look at the y-coordinates here, we want them to be, greater than 0, I should have said before. We're looking for when these are greater than 0. So if you look at this graph, we've got negative values of y all here. Our positive values of y are here and here. And so I need to find out how I can express that in terms of x. What are my x values that correspond to this? So if you look at what's happening here, effectively, your whole graph is going to continue on up like this. So any value of x that is less than negative 3 will give you a positive value of y. Okay, I'll just say that again. Any value of x that's less than negative 3, so any value, negative 4, negative 5, negative 6, it's going to give you a positive y value. So x is less than negative 3 is part of my solution to this question. Then, again, if I look at the other end, what I'm looking at here is any x value that's greater than negative 1 is also going to give me a positive y value. So I'm looking there at greater than negative 1. And so those are my answers, and I have to leave them as two separate inequalities because I can't write them as one, okay? I have to leave them as two separate ones. Now the reason I can't write them as one is if you imagine trying to write them as one, you say x is less than negative 3, x is greater than negative 1. I would challenge you that you can't think of a number that works for both those things. Okay, you can't think of a number that is greater than negative 1 and also less than negative 2. Okay, there isn't a number. So therefore you can't write that in one inequality because there is no number that actually satisfies both those inequalities at the same time. What we've got here is actually this. Okay, we've got x is less than negative 3 or x is greater than negative 1. Those are the two sections that generate a positive y value. Okay, so that's where it just changes a bit when it's greater than. And I'll show you another example with greater than as well. So if you look at this one, again, starting off by factorising. Critical values. Like that. Quick sketch. And again, we're looking for the bits where it's greater than or equal to this time, but greater than 0. So we're thinking above the line and above the line. And when I say the line, I mean the x-axis. So above the x-axis there, that's where we know that the y values are going to be positive. They're going to be greater than 0. So this way, I'm looking at x is greater than 5. This way, I'm looking at x is less than negative 7. And now the last bit, again, is just to check the question, because that's equal to there, in the same way as we did with that, the second example, we have to make sure we've got the equal to sign there as well, and we can just write or there as well. So we're looking at x is greater than or equal to 5, or x is less than or equal to negative 7. Those would be your solutions there. Now, as I said at the beginning, this is a kind of a grade 8, grade 9 topic, probably grade 8 at the moment. This is difficult, okay? People find it quite hard to get their heads around the idea of this above the x-axis, below the axis concept. So I'd like you to take your time on this and really just try and explain a little bit about why you end up with two separate inequalities when it's greater than. If you look here, you've got two separate inequalities there, and for that one, whereas you've got just one inequality for when it's below the line, okay, for when it's less than. So please take your time and write some notes on this question. I would like you to copy down all 4 examples, and then please email if you're not sure, okay? Please ask questions if you feel you need to, and have a go at the questions in the booklet. Okay, thank you.